This is lesson 9.2.1. You should be on pages 226 and 227 of your mathematician notebook. At the top, make sure you write 9.2.1, put a box around it, and then you can write next to that dilations. Today, our I can statement is I can dilate a shape on the coordinate plane. Now, if you've ever been to an eye doctor, you might have had your eyes dilated. What happens is they dilate your eyes and your pupils change size. They get really big. Then they go back down to normal size. They don't change shape. All they're doing is changing size. So that's what we're going to be talking about with dilations, is when we change the size of a shape. Just a reminder to make sure to clean up your messes today. Scraps, glue, scissors, pens, calculators, everything needs to be in your bins and cleaned up before you leave. This is the answer key for yesterday's homework, 9.1.2 on pages 3 and 4. Pause this, grade yourself out of 11, make sure it's on your green sheet, make sure you show your work, and then resume the video. The launch for today is a data chat about trends in despair, soaring numbers of unnourished individuals worldwide. So undernourished means not getting enough nutrients, right? Not getting enough food to sustain ourselves with the vitamins and minerals. I want you to write down 2 notices and 2 wonders in your mathematician notebook for the launch. 2 notices, 2 wonders. Pause this video, unpause when you're done with that. The explorer says, remember that when an object is translated, rotated, or reflected, it stays the same size and the same shape, even though it's moving around. For this reason, these type of movements are called rigid transformations. Today, we're going to explore a new transformation that changes how an object looks. Make sure you write down questions, ask your teammate questions if you have them, and I'll be happy to answer them when I return. For our work today, we're actually going to be working on a graph that you need to glue into your mathematician notebook. So pause the video, get this glued in, and then resume when you're ready. Your first job is to label the coordinates A, B, C, and D. So on the graph, we have 4 vertices, we call them, on our shape. The one that's over 2, up 1, we're going to label as A. Over 3, up 1, label as B. C is at 6, 6, and D is at 2, 6. So make sure you label those. What do you think will happen if you multiply each coordinate by 2? What about 1/2? What about -1? -2? -1/2? That's what we're going to explore today. Now remember, we've learned about scale factors before. When we scale up a number by a number that's larger than 1, the shape is going to get larger. If we scale it up by a number less than 1, like a fraction, the shape gets smaller. But today we're going to discover what happens when we multiply by a negative. On your graph, what we're going to do is we're going to graph these new shapes. So there's going to be 5 new shapes on our graph. Now, what I did is I used different colored pens when I did this, just to make it kind of more visually pleasing. But if you just have pencil, that's totally fine too. Maybe you want to use that blue pen for some of them. We are going to write down the new coordinates of each shape, and then we're going to plot them on a graph. Now, just a reminder, our original shape, A, was at 2, 1. B was at 3, 1, C was at 6, 6, and D was at 2, 6. So our first scale factor is a scale factor of 2. That means we're going to take every single x and y value and we're going to multiply them by 2. So for the new A coordinate, I'm going to take 2 times 2, which is 4, 1 times 2, which is 2. For the new B coordinate, 3 times 2 is 6, 1 times 2 is 2. For the new C coordinate, 6 times 2 is 12, 6 times 2 is 12. And for the new D coordinate, 2 times 2 is 4, 6 times 2 is 12. So I took every x and y and multiplied it by that scale factor of 2. Now I'm going to plot those new points and see what happens to the shape. So we're going to go over 4, up 2, over 6, up 2, plot a point, over 12, up 12, plot a point, over 4, up 12, plot a point. And remember, you can always pause this video or rewind if needed, because I know I'll be going pretty fast. So we're going to connect our points, and here we have a new shape. Inside that shape, let's write 2, since that was a scale factor of 2. Now, if you notice, the shape got a lot larger. The shape got bigger. Our next number that we're going to multiply by, our scale factor, is 1/2. So now we're going to take each coordinate from the original A, B, C, D, and we're going to multiply each x and y by half. Half of 2 is 1. Half of 1, I'm going to use decimal form, 0.5. Half of 3 for B is 1.5. Half of 1 is 0.5. Then for 6, half of 6 is 3. Half of 6 is 3. And for D, half of 2 is 1. Half of 6 is 3. So I multiplied every single A, B, C, D, x, and y coordinate by 1/2. Now I'm going to plot those. Over 1, up 1/2. So it's going to be really teeny tiny. Over 1.5, up 0.5. Over 3, up 3, plot a point. And over 1, up 3, plot a point. And we're going to connect the points. Then inside, I'm going to write 1/2. Now, if you've noticed, the shape got smaller. When we multiplied everything by 1/2, the shape got smaller. Now we're going to do the same thing with -1. Going back up to our A, B, C, D, our original coordinates. 2 times -1 is -2. 1 times -1 is -1. 3 times -1 is -3. 1 times -1 is -1. 6 times -1 is -6. -6. -2. -6. So really all I did was I changed all the original coordinates to negative. Now we're going to plot those new points. So we go over -2, down 1, left 3, down 1, left 6, down 6, left 2, down 6, and plot a point. And then we're going to label that one as -1. Now, if you notice, the size of our original shape, it didn't change, but it did get turned around, right? So it looks like it almost went around that origin point, the point 0, 0. We'll have to explore that more. Then with -2, we're going to multiply each coordinate by -2. Now, what you can also do is take this, when we multiplied by 2, take all those and then just make them negative. So -4, -2, -6, -2, -12, -12, -4, -12. Then we're going to plot those points. Left 4, down 2, left 6, down 2, left 12, down 12, and left 4, down 12. And then we can connect our points. And that was a scale factor of -2. So this time the shape did get bigger, but it's in a different quadrant on the graph and just turned around. So the shape got larger and it looks like it was flipped and turned. Then by -1/2, we can take our originals for scale factor of 1/2, and then we can just change all those to negative. So -1, -0.5, negative 1.5, negative 0.5, negative 3, and negative 1, negative 3. Then I'm going to plot those on my graph. So negative 1, left 1, down 0.5, left 1.5, down 0.5, oops, went over too far, left 3, down 3, left 1, down 3. And then I'm going to connect those. It's teeny tiny, and that was by negative 1/2. So the shape still got smaller, but it did rotate, right? It's in a different quadrant, and it looks like it's turned around. So when we multiply by a number bigger than 1, the shape gets bigger. When we multiply by a scale factor less than 1, the shape gets smaller. Now, technically, negative 2 is less than 1. But what we want to think about is that, like, if it's a fraction form, then it gets smaller. If it's whole number 1 or more, or negative 1 or less, it's going to get larger. So the closer to 0, really, the smaller it will be. Make sure all of that is labeled and graphed in your notes. And then for the closure today, some questions I want you to think about. How does the size of a shape change or not change when a shape is dilated? How do the angles change or not change? Do the results of a dilation depend on which multiplier is used? What are things your future self might need to remember when these transformations return in other lessons? So those are all things that we're going to think about and continue to talk about. Before we finish, I want you to make sure that you have this definition written down in your mathematician notebook. A dilation, under the word dilation, is a transformation that changes the size of a figure by a scale factor, by a multiplier, without changing its shape. The shape does not change, the size gets bigger or smaller. Even if it's turned around, flipped around, the shape is still the same. Your homework for tonight is pages 5 and 6. Make sure you show all of your work, and again, make sure you clean up your stations.